Hello everyone, welcome and thank you for joining us. I'm Dr. Jeanette Morgan and I'm with the Psychological and Educational Assessment Center located in Newport Beach, California. For more information about us, we've provided a link below. As independent educational evaluators in California, we are beginning to see that some local educational agencies are utilizing the Patterns of Strengths and Weaknesses method to determine eligibility for special education services due to a specific learning disability. This new trend brings up questions regarding what exactly is it, and is there evidence that it is a valid method to use for identification purposes. There's a lot of information to share, so we will be covering it in two parts. This video is part one, in which Brenda will provide a broad overview of what the method is and how decisions are made. Part two examines what the literature says about the method and answers the question regarding its validity as an identification method. My colleague Brenda Tran has received training in the PSW method and will present part one.
Hi everyone, thank you for joining our video presentation. My name is Brenda Tran and I am a licensed educational psychologist as well as a nationally certified school psychologist. For today's video, we're going to go over one of the methods for identifying a specific learning disability called the Patterns of Strengths and Weaknesses Model, or PSW. Specifically, we're going to go over the Dual Discrepancy Consistency Model. Our goal for this video is to provide you with the working knowledge you need to be able to pick up an evaluation and understand the concepts and terminology. So let's get started.
These are the objectives for today's presentation. First, we'll introduce you to the different PSW models. Then we will specifically provide you with an overview of the Dual Discrepancy Consistency Model. And lastly, we will provide an overview of the Cross-Battery Assessment software system. You can jump ahead to any section of this presentation by using the timestamps in the description box of this video.
Let's start with an introduction to the different models of patterns of strengths and weaknesses.
This method of identifying a specific learning disability has different models to it. That is, there are different ways of identifying a specific learning disability using a PSW framework. The first model, and arguably the most widely used model, is the Dual Discrepancy Consistency Model, or DDC. This model is closely associated with cross-battery assessment. By closely associated, I mean that they were developed by the same scholars and are intended to be used together, but they are still considered distinct. In other words, cross-battery assessment operationalizes the DDC model. If the DDC model is the blueprint, cross-battery assessment is the methodology you would use to build it. Later in this presentation, we will be reviewing the cross-battery assessment software system that is often used in tandem when using the DDC model. Another PSW model is Milton-Dean's processing model. There's the discrepancy consistency model, concordance discordance model, and core selective evaluation process. If you are reviewing or conducting an evaluation using the PSW framework, it will be important to know which PSW model is being used. This will help you to know the rules that are being used to identify a specific learning disability. Although there are several major similarities between these models, they also have key differences, such as how they calculate or determine strengths and weaknesses. We will be discussing the DDC model in this video. So from here on out, if I say PSW model, I am referring specifically to the DDC model.
Now that we've gone over the different models of PSW, we're going to be focusing in on the Dual Discrepancy Consistency Model. If you're interested in learning about the other models of PSW, we're going to be releasing upcoming videos on our YouTube channel to cover that information. In this next section, I'm going to provide you with a broad overview of the DDC model. You can find more detailed information in the book called Essentials for Cross-Battery Assessment, written by Flanagan and Ortiz. Later in the presentation, I'm going to provide you with more technical information about these broad concepts when we go over the cross-battery assessment software system. So let's get started.
This is a visual representation of the PSW model. This is the same visual that is used in the book written by the scholars of this model, called The Essentials of Cross-Battery Assessment. The top oval represents one of the first criteria that examiners will be assessing for, and that is that the individual must possess average or better overall cognitive ability, excluding processing weaknesses. According to this model, a full-scale IQ score is not necessarily a fair indicator of overall ability because it is including the student's cognitive weaknesses. This model looks only at an aggregate of the student's processing strengths. Another term you might hear for this criterion is that the individual must have an otherwise normal cognitive profile. In the evaluations using this PSW model, the terms G-value score or facilitating cognitive composite, FCC, may also be used. A G-value is a numerical value that represents the likelihood that an individual possesses at least average overall cognitive ability. A G-value ranges from 0 to 1, and values greater than 0.6 are considered to be indicative of general overall average ability. FCC refers to the individual's overall general ability based on strengths. This score will likely be shown as a standard score. I will show you in more detail how this criterion is measured by the examiner when we review the cross-battery assessment software program. The next criterion of this model is to identify a cognitive weakness or deficit by assessing the individual's processing areas. Examples of the processing areas are provided by the Title V California regulations. According to this model, a weakness or deficit is acceptable to meet this criterion. A weakness is defined typically as performance on a standardized norm reference test below the average range, which is a standard score between 85 and 89. A deficit is defined as a standard score below 85. Another aspect of this model is that the cognitive weaknesses or deficits need to be domain-specific. That is, the areas of weakness or deficit are limited in scope. They are not pervasive and do not affect all or nearly all areas of cognition. So how do we know if the areas of weakness are domain-specific? The authors of this model argue that it is confirmed by finding a statistically significant difference between overall ability and the areas of weakness, and this difference should be uncommon in the general population. The authors define uncommon as occurring in less than 5% of the population. The cross-battery assessment software program helps examiners to make these calculations. The next criterion of this model is to identify an academic area of weakness or deficit. The potential academic areas to be assessed are provided by the Title V California regulations. A weakness or deficit is acceptable to meet this criterion. The academic weaknesses need to be unexpected given the individual's overall cognitive potential. Once again, this is calculated by identifying an academic score significantly discrepant from the individual's overall ability, and that discrepancy should be uncommon in the general population. These two areas of discrepancy that we just reviewed refers to the dual discrepancy requirements in the name Dual Discrepancy Consistency Model. That is, there needed to be found a discrepancy between overall cognitive ability based on strengths and the weaknesses or deficits found in the areas of cognitive processing and academic skills. The last major criterion of this model is that there needs to be a cognitive aptitude achievement consistency. This refers to the requirement that the weaknesses or deficits between cognitive processing and academic skills needs to be consistent, which means that they need to have a research-based link. An example of this would be that the individual's processing weakness is phonological processing, and their academic weakness is basic reading. Those two areas have a research-based link. That is, we know through empirical studies that phonological processing directly influences basic reading skills. This criterion refers to the consistency requirement in the name Dual Discrepancy Consistency Model. That is a broad overview of the Dual Discrepancy Consistency Model. Now I'll go into a bit more about how the examiner is responsible for assessing these criteria. This is a broad overview of the assessment and analysis required for PSW. The examiner assesses all major areas of academic achievement, such as reading, writing, math, and oral language. The academic areas assessed should be informed by the referral concern. The examiner assesses all 7 CHC broad domains of cognitive processing areas. CHC refers to the Cattell-Horn-Carroll broad domains, which include crystallized intelligence, fluid reasoning, long-term storage and retrieval, short-term memory, visual processing, auditory processing, and processing speed. Although only the 7 CHC broad domains are required to be assessed, the authors recommend that practitioners review current research to see which cognitive abilities, broad or narrow, are related to the academic area of concern. I should note here that there is currently no published norm reference test that covers all 7 CHC broad domains and additional narrow abilities to make up a comprehensive assessment. So it is likely that in order to assess all required areas to fulfill the DDC model, an examiner will have to use multiple test measures. This is why the term cross-battery assessment becomes linked with the DDC model. An examiner typically needs to use multiple test measures and assess across batteries to measure all relevant areas. The examiner also needs to ensure that all of the scores they obtain while assessing the individual are cohesive, meaning that the scores hang together and are not significantly discrepant from one another. If an individual does yield significantly discrepant scores, the examiner is required to follow up on those scores. For example, if an examiner administered 2 subtests and the individual yielded an average standard score of 90 on one subtest and a below average score of 75 on the other subtest, it is the responsibility of the examiner to investigate further until they obtain a representative composite score for the individual. This may include potentially administering 1 or more subtests from the same test or a different test measuring the same ability. The examiner uses the cross-battery assessment software program to indicate whether a score is considered a strength or a weakness. If a score is determined to be a strength, the program uses that score to help calculate the individual's cognitive potential. If a score is determined to be a weakness, then it is analyzed to see if there is consistency with another area of weakness or deficit. The authors emphasize that supporting data should be used whenever the examiner is making a professional judgment, such as determining strengths or weaknesses. It is the responsibility of the examiner to conduct a comprehensive evaluation and determine with supporting data if the individual demonstrates a profile consistent with a specific learning disability. It's important to note that the authors of the DDC model emphasize the importance of using multiple sources of data, such as curriculum-based measurements, teacher input, parent input, observations, work samples, for example, and not just standardized tests. Furthermore, the authors state that when the examiners are analyzing their data, they should not rely on hard and fast cutoffs or use a one-size-fits-all approach when determining strengths or weaknesses or eligibility recommendations. As with all methods of identifying a specific learning disability, the examiner must consider exclusionary criteria and the need for special education services.
Now that we've reviewed the DDC model, I'm going to give you a brief tour of the cross-battery assessment software system. This program was developed by the same scholars who developed the DDC model. They were meant to be used together. In the upcoming slides, I'm going to show you screenshots of the program and illustrate for you how examiners input their scores and use their professional judgments to analyze their data. My goal is to illustrate for you the level of analysis required and professional judgments required by the examiner, and thereby highlighting the importance of having a lot of supporting evidence to justify their decisions when determining a specific learning disability. So let's get started.
After all testing is completed and scored by the examiner, the scores are entered into the XBAS program. In our example, the examiner used the Woodcock-Johnson test of cognitive abilities to measure cognitive and processing areas. This is a screenshot of a portion of the page the examiner would see when they enter their scores. On the left, you can see the different CHC broad domains that the Woodcock-Johnson is measuring. Here, the examiner entered their standard scores for each composite and subtest. In the middle, the XBAS program calculates whether the scores are cohesive. It does this by measuring whether the scores are significantly discrepant, and if so, whether that discrepancy is uncommon in the general population, which, when determining cohesion, is less than 10% of the general population. The program will then provide the examiner with its recommendation, which you can see reads cohesive, clinical judgment needed, and sometimes it reads not cohesive. On the right side, the program provides recommendations on whether follow-up is needed given the provided scores. Some examples of what the program might read include no, follow-up is not considered necessary, yes, recommended for lowest score, and maybe for the lowest score. The program provides the examiner with brief descriptions of why it is giving a particular recommendation. It is left up to the professional judgment of the examiner whether or not to follow up on their scores. The authors note that determination of whether follow-up assessment may be necessary is made irrespective of composite cohesion. This means that it depends on the professional judgment of the examiner and whether they determine the composite is representative of the individual's skills given all of the data. So what is the examiner required to do? Even if the XBAS program recommends follow-up, that does not necessarily mean that the examiner has to administer more tests. It does mean that the examiner needs supporting data to make a determination if the test composite in question is representative of an individual's abilities. This supporting data could be additional testing, or it could be other data sources such as informal assessments, review of previous evaluations, work samples, etc. For the remaining slides, we will be focusing on this fluid reasoning composite for the purpose of illustrating more of how this program is utilized. Here we have subtest scores where follow-up was recommended for the lowest score. In this example, we will assume the examiner decided to administer more subtests. The next slide will illustrate the next steps. This is a screenshot of the portion of the program referred to as the XBA Analyzer. This is where the examiner inputs their scores that needed additional subtests to determine cohesiveness. If no additional testing was needed, this page would not be used. In our example, our examiner decided to administer additional subtests to their Woodcock-Johnson fluid reasoning composite. We start with the two Woodcock-Johnson subtests. Let's say the examiner decided to administer one subtest from the WISC. With the added score, the XBAS calculates which of the provided scores are cohesive. In this example, it determined that the standard score of 81 and 80 were cohesive, and it kicked off the subtest with the standard score of 106, indicating that it is divergent, which means statistically different from the other scores. The authors state that even if a score is excluded from a composite, the score should still be included in the psychoeducational report, and these scores should be explored and explained to the best of the practitioner's ability. In fact, the authors recommend a qualitative analysis of task demands and task characteristics to generate hypotheses regarding the reason for the divergent scores. To illustrate for you more about the level of professional judgment required by the examiner, as well as the importance of supporting data when determining representative scores, I will show you what happens if the examiner decided to administer two subtests from the WISC. Here, the examiner administered two subtests from the WISC instead of one. In this example, our student performed in such a way that created two groupings of subtest scores, two lower scores indicated in green and two higher scores indicated in blue. The two groupings create very different composite scores. One composite score is a standard score of 78 and one is a standard score of 110. So which composite is actually representative of the student's fluid reasoning ability? Well, it is the examiner's responsibility to analyze this performance and answer that question given all of their assessment data. To add more clinical judgment into this mix, if the examiner selects the Evaluate Score Configuration button, the XBAS program can provide up to 6 different score configurations that I will quickly go through with you. The XBAS can include all 4 subtest scores, exclude the lowest subtest score, exclude the highest subtest score, exclude the highest and the lowest subtest score, exclude the 2 lowest subtest scores, and exclude the 2 highest subtest scores. Again, the type of score configuration that is ultimately used depends on the professional judgment of the examiner, which should be supported by additional data such as analysis of task characteristics, analysis of the processing demands that might affect a student's performance on a particular subtest, and other clinical observations. This decision-making process should be detailed in the psychoeducational report. To reiterate, it is the responsibility of the examiner to analyze all of the aggregate data available and determine which subtest scores are representative of the individual's abilities. Once the decided upon subtest scores are configured into overall composite scores, the examiner moves on to determining which composite scores are considered to be strengths or weaknesses. Let's assume in our example that the examiner decided to keep the 2 separate fluid reasoning composite scores. Now that we have all of our necessary scores, let's move on to determining strengths and weaknesses. This is a screenshot of the portion of the program referred to as the Strength and Weaknesses Indicator. This is where the examiner analyzes their cohesive composite scores for all 7 CHC broad domains and determines if each score is a strength or a weakness. Here, you only see 4 of the CHC broad domains, but the examiner would have access to all 7 domains in their program. If the examiner determines that a score is a strength, they select the Strength button, the score turns green, and the XBAS program uses that score to help calculate the individual's cognitive potential. If a score is determined to be a weakness, the examiner selects the Weakness button. The score turns red, and it is available to be analyzed to determine if there is consistency with another area of weakness or deficit. So how does the examiner determine if a composite score is a strength or a weakness? According to the XBAS software, determination of strengths and weaknesses is a judgment that is made by the evaluator based on what is known about the examinee. In general, ability and processing strengths facilitate learning and academic performance, whereas weaknesses inhibit learning and academic performance. The authors state that typically scores that fall in the average range or higher likely facilitate learning, and scores that fall below average or lower likely inhibit learning. So what scores are considered to be in the average range? In their book, the authors state that for norm reference standardized assessments, strengths are considered to be standard scores at or above 90, and weaknesses are standard scores at or below 80. The range in between is considered inconclusive, which should prompt the examiner to look at additional sources of data. However, the authors also write that guidance for determining strengths and weaknesses may be specific for the test instruments used. Overall, the authors only provide guidance on determining strengths and weaknesses. They state that sole reliance on standard scores and strict cutoff points should be avoided in any diagnostic approach to determining a specific learning disability. So when reviewing or conducting an evaluation using a PSW model, there are several important factors to consider, such as what scores will be considered average. Will the examiner use the test measures definition of average, or a more general definition like standard scores between 90 and 109? Equally important, given that hard cutoffs are discouraged, is what supporting data was used to make determinations about inconclusive scores. Going back to our example, because our examiner decided to keep 2 composite scores for fluid reasoning, they had the option to indicate both a strength and a weakness for this broad domain. They will need to explain their rationale and analysis in their psychoeducational report. Once all strengths and weaknesses have been indicated, The examiner moves on to analyzing the individual's overall profile using the DDC model. This is a screenshot of one of the last steps in the XBAS program. After all of the scores have been input and all of the strengths and weaknesses have been determined, this is where the XBAS program will help the examiner to analyze if the individual's profile is consistent with a specific learning disability, according to the DDC model. The program analyzes all of the components that we have reviewed thus far. Does the individual possess average or better overall cognitive ability? Is there evidence of domain-specific weaknesses in cognitive functioning? Is there evidence of unexpected underachievement? Is there evidence of below-average aptitude achievement consistency? The program will then provide a recommendation about whether the individual's profile meets criteria within the DDC model. Again, the authors emphasize that the results of the XBAS software does not automatically confirm or rule out the presence of a specific learning disability. The student's profile must be considered within the context of the entire case history of the individual. In addition, other data gathered through multiple methods need to be considered, as well as exclusionary criteria. This concludes a brief summary of how the XBAS program can be used by practitioners. It is a lot of information that ultimately highlights how much training and thorough analysis is required to use this program and model effectively and as intended.
We've reached the end of our presentation, and I want to thank you so much for watching. I hope that provided you with a lot of useful information about what the DDC model looks like and how it should be used by practitioners. Please check out the rest of our YouTube channel for additional videos surrounding psychoeducational evaluations and other educational supports. I'm Brenda Tran, licensed educational psychologist, and I will see you next time.